Are you able to see the slides?
Yes, sir. Yes, sir.
Okay.
So, once again, a very good morning to one and all present here. So, today we have experts from IIT Kanpur, Professor S. Chakrabarti, sir. So, I welcome you, sir, in this online faculty development program organized by the Electrical Engineering Department, Rajki Engineering College, Sonbhadra, on energy management and planning in a smart city for sustainable development. So let me allow me to cite your brief biography for the participants. So Professor Chakrabarti sir has completed his PhD in electrical engineering from Memorial University of Newfoundland, Canada in 2006. Before completing PhD, he worked in Asia Brown Boveri ABB Limited India and Bhava Atomic Research Center India. After completing PhD, he worked as a special scientist in University of Cyprus and first as a research associate and then as a lecturer in Queensland University of Technology, Brisbane, Australia since 2009. He has been working in the Department of Electrical Engineering, Indian Institute of Technology, Kanpur, India, where he is currently a chair professor. His research interests are in the area of power system, state estimation, power system dynamics and stability, modeling of power system loads, smart grid, microgrid. He is an editor of various reputed journals, IEEE Transaction and Power System, editor of IEEE Power Engineering Lectures, associate editor of International Journal of Electric Power Energy System, and associate editor of IET Generation Transmission and Distribution. So once again, I welcome you, sir, and I request you to kindly start your presentation.
Okay, thank you very much. And first of all, I apologize for the delay. There was some network issues. Let me put it on the presentation mode. Okay. The slides are visible, correct?
Yes, sir. Yes, sir. It is visible.
And this presentation is about a smart city pilot project that we executed on IIT Kanpur campus. It was actually part of the initiative from the Ministry of Power, Government of India. Now, as I'll be going through the slides, if you have any questions from the audience, please stop me and feel free to ask questions, okay? There is no need to keep your questions till the end, okay? You can ask anytime. Okay. So, these are the locations for the smart city pilot projects which were sanctioned by the Ministry of Power. There were actually 14 projects which were sanctioned initially, but then 2 of them were dropped. And finally, 12 pilot projects reached execution stage. So in the map, you can see those 12 pilot project locations. And one of them is IIT Kanpur. I don't know, this pointer is not working here anyway. One of the locations is IIT Kanpur here. And the IIT Kanpur Smart City project is equally funded by the Ministry of Power and IIT Kanpur. So it was 50-50 partnership. Okay. And if you see the note, the list of projects that are there at the right hand side corner at the bottom, IIT Kanpur is the only academic institute who are executing this project. Other agencies are utilities. Okay, so that actually brings a lot of uniqueness to this project and a lot of research angle. Being an academic institute, we at all stages we had made sure that you can actually play with the system. Okay? We had developed our own applications and integrated to the software and hardware platform, and all our students, PDFs, they're all whatever algorithms and methodologies we are developing in distribution systems. So those are being tested and validated on these platforms nowadays. And this is the objective was to develop a smart city prototype which could be replicated outside in the India, especially in the Indian context. So that was the objective of this project. And also, when you talk about a smart city, many things may come into picture or to your mind. Smart buildings, smart roads, smart lighting, everything has to be smart. Smart air conditioning, for example, smart traffic management. But here in this project, we looked into only the electrical aspects of smart city. So our scopes were very limited. So we looked into only the electrical aspects of a smart city. So let's keep that in mind. So a little bit about the project objectives and what are the scopes of this project. IIT Kanpur campus was chosen as the installation site. Okay. And I believe some of you might have visited our campus. This campus spans around 1,000 acres, that is roughly 4 kilometers square. And we have currently not 10,000, slightly more than that, probably around 11 or 12,000 people living here, pre-corona period, of course, including the students. And the objective was to develop a smart city, the electrical infrastructure of a smart city, keeping in mind the state-of-the-art technologies that are available in India, especially in the Indian market. Okay? We should not bring some technology which is not available in the Indian market. Okay? So those are the things that we had to keep in mind. And then once we had the setup, the idea was to identify the key challenges in smart city deployment. Okay, what are the challenges that you foresee? If you are going to replicate this kind of setup outside the um, uh, campus in a typical Indian city. So we tried to address those challenges in this project. Okay. And finally, this test bed. This is actually a test bed, living state test bed, and this is being used as a training and demonstration platform as a research platform for academicians all over India and as well as utilities. Okay, from time to time we conduct workshops where we invite people from utilities and we give them hands-on training. So that was also one of the objectives of this project. So with this background, let's talk about what is included in this project. There are four major components. One is the supervisory control and data acquisition system. All our substations are now having SCADA. We will talk about all these elements one by one briefly. We also have advanced metering infrastructure, that is AMI, including the smart meters. We also went inside some of the houses in the campus and implemented home automation solution. So that was actually a very unique component of this project, and none of the other pilot projects actually could get into inside the houses. Okay, mostly they were concentrating over SCADA and AMI. Now, we also have significant presence of solar PV in our campus. So from this project, we had installed 100 kilowatt of rooftop solar PV. Additionally, we have around 2 megawatt of solar PV in our campus from some other sources. Okay, and then these four components were integrated into a so-called system integration platform. So, of course, it is not a very easy task. Okay, as you can imagine. And we had used ESB architecture, enterprise service bus, just to make sure that we have interoperability, which is of course a significant issue in distribution systems. Okay, if you buy components from different vendors, at the end of the day, you might figure out that they're not talking to each other. So that's interoperability problem. Okay? And then this platform is supposed to be working as a training demonstration as well as research platform for utilities, industries, as well as academic institutes. Okay. Now, a little bit about the electrical system that we have included in this project. IIT Kanpur receives power at it's 33 by 11 kV substation. Now, our total sanction load as of now is 10.5 MVA, but it's going to increase very soon. And when we say sanction load, it means that if we exceed this amount of load, we have to pay a large amount of penalty. Okay. And currently we have not 10 but 11 number of 11 kV by 415 volt substations. Okay. And our 11 kV network is entirely underground. Okay. So just and RTUs are installed in all the substations now, and data from those RTUs are sent. Actually, the RTUs actually collect measurements from multifunction transducers, and from there, their data is collected, sent to the RTUs, and then RTU sends those information to our control center. Okay. And that's part of the SCADA system. And also we have rooftop solar PV. Each individual house is having 5 kilowatt peak solar PV. We have some pictures of those houses in this some of the slides. And those houses are also having home automation installed. Okay. And AMI also is in those houses are having smart meters as well as some. It's not 7 student hostels only now. At the moment, majority of our large buildings are having smart meters installed. Okay. So that is the electrical infrastructure that was included in the smart city pilot. So these are the functionalities: smart home. We will talk about briefly all these things, and advanced metering infrastructure, including smart meters and the associated communication infrastructure. We had upgraded our substation into modern substation. We have a full-fledged control center with a big display where you can see online diagram of the entire campus, power consumptions, flow of power, whether a breaker is on or off. Very standard configuration is there. What you find in the utility control centers. Okay. Then we are integrating those renewable energy sources, that is solar PV. That's also part of the project, and some research work also went into the integration issues. Okay, we'll talk about that. And the moment you have large number of smart meters and the large volume of data coming to a control center, you have to have an IT infrastructure to manage that data. So that's why we have to have IT infrastructure. We have full-fledged servers which are dedicated to AMI, to SCADA. We have a full-fledged server room in our control center. And things are made modular or interoperable with the use of ESB, Enterprise Service Bus, and also storage management. Some of the houses are also having batteries. Okay, so that is also there. So this is the overall system architecture. As you can see, all the way from the substations till the individual houses, we need to have a communication medium, very well lit communication infrastructure. So that's one of the requirements of smart city or smart grid. Actually, smart grid is basically the marriage of electrical layer as well as communication and IT layer, right? So this is the overall architecture of the smart city, the electrical infrastructure that we have in the campus. Our SCADA, some of the SCADA functionalities which are listed here, as you have already figured out, these are very standard functionalities. Okay, one of the objectives and requirements of this project was like this. Just because we are an academic institute, we did not have freedom to do things in an ad hoc manner. The idea being this kind of setup should be replicable outside the campus. So all the installations had to be following standard norms. Okay, so that was one of the requirements. So we had a very industry standard SCADA installation in all substations. Okay, and the functionalities that you see here, they are very standard functionalities: communications with RTU, data processing, data storage. This data storage is actually a very important information. Okay, by using that, you can do various things. For example, you can model your load. So this historical data will help you in finding load forecasting models. Okay, that's one thing. You can do a post-mortem analysis. Something wrong happens in your system, you can fetch the data afterwards and try to point out what went wrong. So that is also there. Okay. Energy management of metered feeders. So this is something it's not done very much as of now, but as research projects we have taken up these works. For example, we can implement demand response. Okay, some of the heavy, during heavy demand period, we can switch off some of the loads. So those things are possible. But the bottom line is that whenever you are trying to implement those control or decision mechanisms, first of all, you have to know what is going on in your system. So that's why you need a monitoring mechanism. And SCADA is this monitoring mechanism, right? And also in the control center, we have a large display where a single line diagram of the entire network, color diagram is depicted. And sitting in the control center, you can figure out what is going wrong or right in the system. Okay. And standard functions like switchgear control, treat, restore command, permit to work, etc. Okay. So this is our SCADA architecture. The RTU that you are seeing here, it's made by Husky. Husky is an Indian manufacturer. It's not Husky. Synergy is the Indian manufacturer. Husky is the trademark for their RTU. Okay, so Synergy is an Indian company. Okay, so they're very efficient, and this SCADA installation was done by Synergy. Okay, and those the left-hand side. Unfortunately, the marker is not working, but if you look at the left-hand side and bottom corner, left bottom, you see those small boxes, MFM, the multifunction meters. Okay, they are basically transducers. So they sense different types of measurements or status, maybe circuit breaker status, flow of current, voltage magnitude, etc., real power, reactive power. So those measurements are communicated to the RTU. And this is done typically every 2 to 5 seconds. Okay. And on the right-hand side, bottom part, you see the protocols that are used. You see, these are very standard protocols which are used in the utilities. Okay. In the campus also, we have used those protocols. All right. And then we were fortunate in one sense that we had a very well-laid Ethernet infrastructure in our campus, and we explored it fully. Okay. So that was something we could explore. Using that Ethernet architecture, we could collect the information from different substations in the control center. So let's move forward. This is one picture of our control room where you can displays, and many types of displays are possible. On the right-hand side top corner, what you're seeing is the complete single line diagram of the system. You can actually give the full screen as well. Right? I think we have another picture. Yeah. So this is the single line diagram of the entire campus. So you can This is very user friendly, and you can do whatever you want with this kind of setup, right? You can actually click on individual substations, zoom in, and have a look into individual substations. So those things are possible. Let me know if there is any question so far. Okay. I think this shows one historical data trend. Okay, so one trend data is shown over here, right? This is a zoomed version of one of the substations, substation number 4. Okay, you can legend, color, etc. Those are customizable. So this is something we can give a first-hand information of what is going on in your substation. As of now, we are using only monitoring function, but we can control as well. Right? So that control functionality we have tested. So let's come to the next part, that is advanced metering infrastructure. Talk about advanced metering infrastructure. It's not about smart meters only, so let's keep that in mind. AMI is not only about smart meters. Along with the smart meter, there is a communication infrastructure and data management system. Okay, so smart meter, of course, will be there, and all our smart meters are Indian standard 16444 compliant. Well, at least the vendor told that we also tested that. But the problem at that time was that the standard was newly introduced, and there used to be big queues in the testing agencies. At that point, there were only 2 testing agencies. One was AIRDA, another was CPI. So, and there was a huge amount of number of pending smart meters there. So we could not really get the certificate, but the testing was done in lab and the vendor's premise. So these are compliant. Okay. And they have standard features like net metering, tamper-proof feature, remote connect, disconnect, etc. Let's talk about smart meter network. Okay. See, it's not sufficient only to have those smart meters. Along with the smart meters, we also have to have the communication infrastructure. So this communication infrastructure is there. See, usually what happens, there are these, you see that word DCU, this is data concentrating unit. Okay. So typically, this is the architecture. Number of smart meters communicate to a DCU. And a DCU aggregates the data, and then it sends to the control center. Okay. And another important thing is that, of course, from smart meter to DCU, we were using Wi-Fi, RF, Ethernet network, wherever things were available. And sometimes deliberately we tried different communication technologies, because that was the directive from the ministry that we do try different communication technologies. Okay. And then integration of MDMAs with SCADA. Okay, so now here we are talking about a very important thing. Let's notice this. SCADA data refresh rate is 2 to 5 seconds, let's say. Okay. Every 2 to 5 seconds, the multifunction transducers are pulled. Now, and they are transmitted to the control center as and when they come. But the smart meters, they send data. Typically, if you're in a utility, they will send you data every 10 minutes or 15 minutes. Okay. In campus, we are using 5 minutes, which is actually a bit high refresh rate. But anyway, we wanted to do some more studies with high resolution data. And their formats are also different. Protocols are different. Okay. So now, when you try to combine SCADA data with MDMAs, the AMI data, it's not an easy task. Their timestamps are different, refresh rates are different, protocols are different, even their accuracy levels are different. Okay, so that is something we are trying to address. And one more important thing is that if you want to handle this large amount of data, you have to have an IT infrastructure. So that's also has to be in place. Let's move forward. So this is the overall AMI infrastructure that we have. In some cases, I think if you look at the left-hand side bottom block, on top of it, there is one thing written repeater. That was interesting in the sense, typically what happens if you go outside in a typical smart meter installation, smart meters are installed outside the houses. Okay, but for some reason, in our campus, the meters were located inside the houses, close to the distribution box. And then, if you want to access the meter data, there were 2-3 walls, brick walls. Okay, so that was somehow hindering the signal. Okay, so we had to use signal repeaters in some places. So that was again a learning experience. Okay, all right. Let's move forward. So let's talk about the renewable integration part. Uh, just once again, the network keeps resetting from time to time, so I'll just refresh the network connection. There's some issue with the network. Are you able to hear me now? Hello?
Yes, sir.
Okay.
Yes, sir.
Thank you. So please keep responding, otherwise I will see that I'm disconnected. Okay. All right. So this is about the renewable integration that happened in this project. So solar PVs were there. So the idea was that the solar power, first of all, tries to meet the demand inside the house, and then if there is something extra, that goes into the grid. Okay, so that's how. And the metering is done actually behind the connection. So that means if a consumer consumes or uses solar power during daytime, he or she actually reduces the electricity bill. Okay, so that's one advantage that you get in place of allowing us to use their rooftops. Okay, because once you install the solar PVs on the rooftop, half of the rooftop is gone. You cannot really use that. Okay. So that was the kind of incentive, we can say, right? I think we have a better picture or scheme for this solar integration. Okay, so this is one of the houses, not my house. Not my house is not so well kept, by the way. One of the houses, you see that on the rooftop there is a solar panel. This is actually half of the total installation. We have 5 kilowatt peak installation, and this is what you are seeing in this picture on the rooftop is actually 2.5 kilowatt. Other half is actually hidden in the, it's on the back side. Okay. The angle of tilt has to be decided carefully. In Kanpur, if you see the latitude, it should be equal to the latitude. Then only you can capture sunlight for the most part of the day. Okay. So that was 26 degrees for Kanpur. All right. So this is something we have to be careful about when you are installing solar PV. Then So we in individual houses had 5 kilowatt solar PV and 20 such houses. And out of these 20 houses, 4 houses actually had a battery as well. Okay. So when the house, for those battery connected houses, we had used the so-called hybrid inverters. Hybrid in the sense that they could actually connect to grid, connect to battery, connect to households. Okay, so they can actually work offline as well as on grid. So those inverters we are calling hybrid inverters. At that point, it was not. I'm talking about 2000, let's say 16, 17. At that point, it was not so common in the Indian market. I think still it is not so common. These hybrid inverters. Okay, so we had to go into vendors' premises. We had to go through a lot of customization process. All right. So we'll talk a little bit more about this system very soon. What exactly we are doing with this solar PV and also especially with the battery. We'll talk about that. Home area network, the final or fourth part. Okay. So here what we are doing inside the houses, we are trying to control the loads. We have a central controller in the houses, and some of the loads were made controllable by with the use of wireless enabled MCPs or switches, wireless enabled switches. Okay, so remotely or from inside the house, you could actually control those appliances. So why are we trying to do this? You might have figured out already. We are trying to implement demand response. Okay. So when the utility is going through a big demand period, if if you shut down some of your loads, then it's actually advantageous in the sense you have to pay less. Why you have to pay less? Because if you are having a differential tariff or time of use tariff scheme, if you are consuming more during the peak demand period, you have to pay more. So if you can shift or divert some of your loads from peak demand period or peak period to off peak period, it actually results into saving in terms of the electricity cost. Okay. And what is the advantage of the utility? Utility is borrowing power from somebody, right? So if they borrow less power during the peak demand period, they have to pay less. So it's a win-win situation, both for the utility and also for you, for the consumer. Okay, so that's something we try to implement. But one basic requirement for there is that you have to be able to control the loads. So that is something we were able to do with the use of this home automation, and that was the purpose of installing home automation system. And then at the end of the day, you have to integrate all these 4 components: SCADA, AMI, home automation, and solar PV. And all these are seamlessly integrated into our system integration platform. Again, we have talked about SCADA and AMI. Now the protocol, refresh rate, the home automation, and solar inverter, they're also different. Okay, so all these different protocol data, having different refresh rates, accuracy levels, they have to be brought into the same platform. Because otherwise, you would not be able to implement applications like this demand response. This demand response, by the way, is coming in a big way. This is going to be a big tool. It actually adds a lot of flexibility to the system operator. So it's a flexibility tool, you can say. This demand response. Okay. And these loads could actually be controlled through our central software, or as well as by the individual from the utility, as well as by the consumer. And there was a we have a mobile application through which also loads can be controlled, right? But everything comes with a price, and we also have to go through a difficult phase. Difficult in the sense, here I'm talking about the social aspects. So this is also not negligible. Okay. See, all these installations, if you are going to retrofit an existing house, which is not smart house or the so-called smart house, you are thinking of replacing the existing distribution box. It's not an easy task. Half a dozen people will move around your house for half a dozen of hours. It's not an easy task, very incomfort. You may find it very inconvenient. Okay? And they had to modify the wirings. They had to drill the walls in some places. So there was a kind of disturbance for the inmates in the houses. Okay, so that was something we had to go through, and that problem will be there. I mean, if you are trying to retrofit an existing house, okay, it's not an easy task. So what we did uh, in terms of electrical installation, we had replaced those distribution boxes with our customized distribution boxes. In that, we had segregated the loads into essential and non-essential. What do we mean by essential and non-essential? Look at the right-hand side picture. You can see two rails. One rail is for non-essential loads. You see the MCBs, and another set of MCBs that are connected to the rail, which are basically supplying to essential loads. Now, essential loads, what we mean by that, the fans, lights, etc. Why essential? Because suppose you are doing some work in your house and somebody just comes in and also remotely turns on the lights and fans. You don't want to have that kind of facility, right? But instead of that, if somebody switches off your air conditioner, let's say for 2 minutes, 5 minutes, it does not cause a huge discomfort. Also, if somebody switches off your geyser, maybe for 2 minutes or 5 minutes, uh, you don't really feel it. Okay, so those are the loads we are calling mainly 15 ampere load in our context. So those are the loads we call non-essential loads. Of course, they're essential, but non-essential in the sense they can be turned off for a small duration, and it will not cause huge discomfort. So that was the idea. And these non-essential loads are the ones which took part in the demand response. Okay, and you in the bottom square point of this yellow highlighted square, you see the controllable, wirelessly controllable MCBs, okay, so through which we are able to control the essential load, non-essential loads. Okay, of course, we can control the essential loads. We also have wireless-enabled switch boxes fitted in addition to individual switch boxes. We could also control fans and lights, but that was just for experimental purpose. We didn't want to include that in demand response. On the left-hand side, you see the overall scheme for our solar integration, both for grid tie. The inverters which were not having a battery connected, we call them grid tie inverters. So this is the overall system integration platform where we were integrating all four subsystems into the same platform. Okay. This is, see what happened. Some of the application software were provided by the vendors, and some of the software applications were developed in our lab. So homegrown developments were also there. And in the tendering stage as well, we had to make sure that we are able to interact or install our applications into the platform that the vendors are supplying. Okay, so that we had to make sure. So the various types of analytics are there in these platforms. Okay, so one of the major objectives of this installation, smart city installation, was to conduct research. Okay, so some of the areas where we are conducting research included here: monitoring and control applications for smart homes. So monitoring, in fact, something which is very often neglected, but monitoring, not only monitoring, visualization is a very important part of system operation as such. See, if you are just dumped with a data, a table full of data, you may not make any sense out of that. But if the same data is presented graphically with some pointers, colors, etc., that might be making sense. So visualization is a very important part of it. Okay? So some of the students are working in that area. Distribution, state estimation, as these SCADA installations are being popular in distribution systems, distribution level state estimation is also getting popular. By state estimation, we mean being able to find out the most likely values of voltage phasors at all the buses, voltage magnitude and phase angle. Correct. And it's a little bit more challenging compared to transmission level. There are many issues like usually the load can be unbalanced, the period can be unbalanced, so you have to go for three-phase estimation. The number of nodes is enormous in a distribution system compared to transmission level. R by X ratios are different. So these are some of the issues that needs to be tackled in a distribution system. It's a estimation problem. Okay. Load forecasting is one very important application for utilities, where this historical data will be of a lot of use. We are making use of this data. Distribution reconfiguration. Sometimes what happens, you would like to reroute the power through some different channels. Okay, there can be many objectives. You may try to reduce the loss in the system, real power loss. You may try to improve your voltage profile. You may try to increase the reliability of the load points. There can be multiple objectives. So distribution utilities usually may do this reconfiguration exercise from time to time. It's not done very frequently, but it's done after some intervals. Okay. Fault detection, isolation, and restoration. It's very important to isolate. First of all, to detect there is a fault, and once you have detected, you have to find out where is the fault. There's fault location is also important. But for all these, you have to have a monitoring mechanism. So we have used our SCADA for locating and identifying the fault in the distribution line, which is actually more challenging compared to transmission lines because of the fact that the impedance is very less in distribution lines. The lines are of very short length. Okay. And especially in the cables, there are mutual couplings, so that's not an easy task. And visual inspection is done if you're talking about a cable. So those are the challenges you have to face when you are trying to identify or locate the fault in a distribution system. Okay. Intelligent billing system is part demand response. These are integrated actually. So demand response is something we were working on. And finally, people were working on improved or enhanced design of the converters to extract solar power during grid connecting, as well as during off-grid operations. Okay. So one thing was clear for these kind of activities. You need actually a multidisciplinary team, people from control systems, power electronics, even economics background, communication, of course. Okay, so different expertise need to be brought in the same table to make this kind of project successful. I think we are nearing the end. Just a few more slides. These are some of the applications which were developed, I think, in our lab for historical data sharing, etc. So these were developed in our labs. Okay, and some of the software also were developed or given supplied by the vendors. So this is one example of a consumer dashboard where you can look into the power consumption. I think the picture that you're seeing over here is solar generation of one individual house. Okay, it gives different various types of information. Right? Now we did not have GIS mapping, but this is of course not GIS mapping, but our researchers used Google Map to identify the locations of the smart city, smart houses. For example, the green ones are the houses where solar PV were installed. You could see that they are pretty dispersed in the campus, which were actually done purposefully just to test our communication. Right. Grade one is the main substation, and likewise other installations are highlighted. Right. This is one home automation solution developed where from a dashboard you could actually control different appliances. That was possible. So yeah, I think we are done. So if you have any question, please let me know.
Dear participants, any queries? Participants, any queries are you having? Sir, I think participants are not having any queries.
Okay. Okay.
Thank you so much, sir, for your valuable time and such a nice, basically a case study. I hope me and myself and other participants had learned a lot, practical situation. So thank you so much, sir. Thank you.
Thank you. And it's an open invitation to all of you. Whenever you find time, please come to our campus. Have a look at our system.
Yeah, definitely, sir. Definitely, sir. Definitely. Thank you, sir. Thank you so much,
Okay.
sir.
Okay. Yeah.
Okay.
Thank you.
Thank you, sir. Thank you, sir.
Okay.
Participants, next lecture will be from 12 o'clock. So till that, you wait and link will be same. And attendance link is shared in message chat box, so you can fill the attendance. Attendance link already shared, so you fill the attendance.